Okay, so this is day 24. Not too much more to go for us. Hopefully you've been doing and you're up to date. So equation expressions. Let's see how we do on this one. Write the expression below using exponents. So again, this I guess just gives you a basic run through, several little topics that we did. So first one, we just want to write that down as an exponential form. So this is 4, the base is 4, the exponent is 4 because it's 4 times itself 4 times, so that's the answer. Write the expression below using exponents, so this would be 3, and it's being multiplied 3 times by itself, and then we're adding that to 5, being multiplied by itself 4 times. Okay, we're not evaluating, we're just rewriting that expression using exponents, making shorter, right? This is 7 to the third, and it says evaluate, so this one you actually have to find the value, so it's 7 times 7 times 7. 7 times 7 is 49. 49 times 7 is, I believe, 343, right? So I might be wrong, but I think it is. I don't have a calculator near me. Evaluate this again. 4 to the fourth power, yikes, plus 6 to the third. For 4 to the power is 4 times 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. And times 4 again is 6. It looks like it's 256. So that's going to be 256. Plus 6 to the third, and 6 to the third is 6 times 6, which is 36, times 6 is going to be 216. So it's 256 plus 216, that gives us 400, and looks like 472. Okay. 5, again, this is just writing that in exponential form. Why am I doing this? No, okay, here we go. Right. Here we go. So it's 2 to the fifth power, because there's 5 2's, plus 4 to the second power. Evaluate. 5 to the second power is 5 times 5. Please, it's not 5 times 2, it's 5 times 5. So that's going to be, I'll write it out. 5 times 5. Right? And we're going to add this to 2 times 2 times 2 times 2 times 2. 5 and 5 is 25. We're going to add to this 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And if you add those up, you get 5, 7. Okay? Move on. Write the expression represents the ratio 4 less than what? Half a number. So it's 4 is 4. Less than means minus. Half is a number. This is half of a number. But it's a turnaround word, so we're going to put the n over 2, and then minus 4. 4 goes in the back. Write an expression again. 6. 6 is 6. Plus is plus. Quotient means division. All right, so I'm going to use a fraction bar to represent that in this case, or of a number, n divided by 4. 6 plus n divided by 4. 12 is 12. More than means plus. The difference is subtraction. So we're subtracting two things. Where is 12 more than the difference of 4 and a number. So we're going to protect that like this. Okay. I'm going to protect that with parentheses. Okay. Otherwise, you end up being 12 plus 4 and then minus n. So you want to find this first. You want to subtract 4 and n and then add it to 12. Okay. You need that to protect that, to the fact that you need to do the subtraction first. Quotient is here's my quotient of 3. Here's 3, right? Quotient of 3, and what am I dividing? I'm dividing 3 and the product of 2 and a number. 2 and a number. The product 2 and a number. 3 over. So let me just clean that up. It would be 3 over 2n. Okay. 5. Write an expression that will help you solve the problem. Expression. Okay, it's not an equation. It doesn't have it. Elise shares 24 cakes with X. Okay, how many cakes that was? So here's an expression of 24 divided by X. That would be my expression. Okay. 6, write an expression. Okay, again, Alan has X baseball cards, so he has this many. Danny has 10 more than Alan. How many baseball cards does Danny have? Wow. So it'd be Danny has 10 more than Alan. So whatever Alan has, do we know how many Alan has? This many cards. So to find out how many Dan has would be x plus 10, right? Write an expression to solve. So you buy X bags of chips for 75 cents. How much did you pay? Well, each bag of chips costs 75 cents, and you can multiply times that X, right? One bag of chips would be 75 cents times 1. Two bags of chips would be 75 cents times 2, and so forth. So it depends on how many bags. The number of the total, it's going to depend on the number of bag of chips. Okay. 1 gallon of gas costs $3.60, and you buy M gallons. So that used to be a long time ago. $3.60. And how much did you spend on gas? Well, it depends how many gallons I put. So it'd be 360 times the number of gallons represented by M. So 360 times M. That would be my expression. And distributive property, yay. Okay. This times this, that times that. So 5 times x is 5x plus 5 times 3. Right, so just to clean things up, that's still 5x, and 5 times 3 is 15. Use a distributive property to write an expression equivalent to 610 plus 10y. So again, so this, we're factoring it out. So, to write an expression, okay, so it doesn't tell you to use the GCF. Okay, it doesn't tell you to use the biggest number possible. But so one of the possibilities is, so what number is common to 6 and 10? Well, in this case, it's the only one. So if I did the ladder method, that comes in handy. 6x, 10y, right? Number goes into 6 and 10, it would be 2. So b2 goes into 6 3 times, so 3x. 2 goes into 10 5 times, so 5y. Nothing else goes into 2 and 3. So remember, this goes out here. 3x will go here. And 5y will go here. Did you need to do the ladder method? No, but it comes in handy because the answer comes right there for you. So just to check, 2 times 3x is 6x, and 2 times 5y is 10y. So I know that this and this are equivalent. Write an expression equivalent to this. So n plus n plus n would be 3n, right? How many n's do you see? 3 n's. Plus, combining like terms, right? Y plus y is 2y. Remember, there's a 1 in front here. Okay, so if you want to add 1n plus 1n plus 1n is 3n. 1y, just 1y again. There's a 1 in there. There's a 1 there. 1y plus 1y is 2y. Use distributive property. Okay, so 7 times 5, and I'll just do this. Okay, so it's going to be 7 times 5, which is 35. M minus, and 7 times 2 in the back here. It's going to be 14. N. Okay. Please don't tell me that was it. No, there's one more page. No, oh, there's more. Okay, so at the bottom, same thing. What is that? X plus x plus x plus x. So it would be 4. How many x's do you see? 4 x's. Right, and this would be 3m. Okay. Oh, good. There's one more page. Okay. Are these two expressions below equivalent? Okay, so how can you tell if they're equivalent? Well, let's see. Over here, I'm going to leave this alone. But on the right side, I know it seems like I can do the distributive property, right? So let's do the distributive property. 5x times 5 is 25x. And then 5x times the 4y over there, ooh, it's not. It's going to be plus 5 times 4 is 20, and you're going to get xy. So this and this is the same, but the 20y and the 20xy are definitely different. So these are not the same. Okay? Let me erase this. Are these two equivalent? Well, let's see. 8x plus 4y. I can't combine them, so I'm going to leave them alone. Here I'm going to do the distributive property. 4 times 2x is 8x. So far, so good. Plus 4 times y is 4y. They look the same? Yes, they do. This has an 8x, this has an 8x, this has a 4y, and this has a 4y, so they're equivalent. Write two equivalent expressions to match the one below. Ooh. Okay, so here we can use our properties, number properties. Okay, so we can use a community property where we can say 4 plus 8x. The community property says I can switch around my addends and it's not going to change. So here's expression 1. Expression 2, what else can I do? Well, I can do that. I can make this look like this, right? What's numbers common between 8 and 4? What's common to 8 and common? What number can go into 8 and 4? Well, 4 can go in there. 4 times what would be 8 would be 2, so I'll write 2x here. And 4 times what would give me that 4 over there would be 1. So if you do the distributive property, you get 4 times 2x equals 8x. 4 times 1 over here gives you 4, so these two, I just created an equivalent expression to that. Okay, so do 2 equivalent expressions. Which 2 are equivalent? Well, let's see. This is equal, I'm going to do the distributive property, it's 3x. 3 times 4 is 12. Okay, is there anything else that looks like this? Yes, C. So A and C are the same, A and C, right? Because they both have 3x, and they both have 12 and 12. Is there anything else the same? Nope. This would be, no, the 3, no. And the bottom one, 3x plus and 3 times 16. This would be 3x plus 18, so nothing else. So the only one that is the same is C and A. Okay, but in A you have to actually do the distributive property, okay, to turn it to 3x plus 12. Okay. Write an expression to show you how you would find the perimeter of the square. Okay, the perimeter is a distance around this. Okay, the distance around. So if you would add this side plus this side plus this side plus this side. So here's an expression to find the perimeter of that square. Well, we don't have values. We don't know how much it is, but it tells you it's S. So it would be S plus S plus S plus S, right? The sum of all those. Or you can write that as S plus S plus S plus S would be just simply 4S, right? So that's how would you find the perimeter of that particular square. This one, perimeter of the rectangle. The perimeter is what? You would add this side plus this side plus this side plus that side. You can write W plus the other W plus the L, and then plus the L for the length. Or to make that a little bit short, how many W's are there? There's 2 W's. Plus, or what? 2L. So that's, or you can write it like that. They're both okay. Write 2 equivalent expressions to match the one below. So we can use a community property again and switch it around. Okay. We can use this. We can, it's like the factoring out. Okay, we can find something that was multiplied by each of the terms inside to give you 12x and 6y. Let's find something in common, the 12x and 6y shared. So here you have possibilities. Okay, so I'm going to pick 2. If I pick 2, what times 2 gives me 12x? It would be 6, right? And what times 2 would give me 6? It would be 3. I can always double check. 2 times 6x is 12x, and 2 times 3y is 6y, so that works. I could have picked 3 to go outside. 3 times what is 12? It would be 4, or 4x. Or 3 times what would be 6y would be 2, or 2y. So again, this is also another possibility that is equal to this particular expression. So we have 1, 2, 3. We can even do another one. We can take, what other number is common to 12 and 6 would be 6. So 6 is outside. 6 times what is 12x is 6 times 2, x. And then 6 times what is 6 is 1y. So 6 times 2x is 12x. 6 times 1y is 1y. So we got 3 different possibilities. 4 different expressions. Okay, which 2 here are equivalent? Well, let's see. Just the last one over here, because in parentheses, I want to remove the parentheses. I'm going to do the distributive property. So I'm going to get 5x. Right? 5 times x is 5x. And I'm multiplying 5 times 2y is 10y. Okay, now good. That none of my expression, I'm going to cross this out even. So they all without parentheses. Okay, is there anything that's the same? Yeah. Letter A and letter D. Okay, so that seems like that's the end of 24. No, it's not. I was completely wrong. Okay, so there's a little bit more. Should have made it a little darker. She baked X cookies and 14 large cookies, X small cookies and 14 large. How many cookies are baked in all? So she made this X plus 14, right? X represents small cookies, and X plus 14, right? And then how many cookies did Irene bake if she made 30 cookies altogether? So write an expression. So okay, so here I know that X small cookies plus the large cookies, they have to add up to 30. Right? And have that extra piece of information now. You can solve this obviously by using an equation. This is an addition equation. I'm going to use inverse operation, which is subtraction. I'm going to go minus 14 here, and obviously I'm going to go minus 14 here. These 14s become 0, X comes down, and 30 minus 14 is 16. So if she made 30 cookies, and 14 of them were the large ones, 16 of them were the small ones. 2, is m equals 7 a solution to this particular inequality? Well, let's see. So if I take m and I put a 7 in there, so I'm going to go 5 times 7 is less than 35. Sorry. 5 times 7 is 35. And is that less than 35? No, it's not. They're equal, but they're not. It's not less. So here, no, 7 is not a solution. Okay, it doesn't make that inequality true. Circle each of the given values that makes the inequality true. So again, here it's 5 times x is less or equal to 30. Well, what if it's 4? 5 times 4, is 5 times 4 less or equal to 30? Yes, because it's 20. 5 times 5 is 25. Is that less or equal to 30? Yes, so that works. 5 times 6 would be 30. Is that less than 30? No, but is that equal to 30? Yes, so that works. 5 times 7 is 35, and 35 is definitely not equal, not less than 30, not even equal to 30. So the last one is that. Solve for x. For this one, you have to solve. Here's my left side. Here's my right side. I want to do an inverse operation, so I'm going to take 20 away from here, right? It's opposite. I'm going to take 20 away on this side. And then I'm going to have x, because these two will be 0. Subtract 20 from both sides, and I'm going to get 35. Is that true? You can always check. For the check, you're going to copy the original equation. And in this case, we know x is 35, so let's substitute 20 plus 35 equals 55. And are both sides the same? Yeah, because this is 55 and this is 55. So we know that our answer is correct. I can just go that. 5 is y equals 3 a solution to the inequality? Well, again, instead of the y, I'm going to replace it with 3. 10 greater than 3 times 3. 10 is greater than 9. So yes, when you substitute 3 here, it is part of the solution. Solve for x. In this case, it's a multiplication that's happening here. Okay, guys, remember 3 times x equals 39. So the opposite of multiplication is division. So I'm going to divide this side and this side by the coefficient, which is 3. 3 divided by 3 is 1. So this becomes 1, or just simply x. 1x or 1x. Okay, you don't need to write the 1. On the right side, 39 divided by 3 is 13. So x equals 13. Is that true? Well, 3 times x is 39. If I replace the x with 13, will that equal 39? 3 times 13. Oops, 13 equals 39. And 39 equals 39, which is what I wanted. Here, it's a subtraction equation. So I'm going to use the inverse of subtraction, which is addition. So I'm going to add 32 to this side. And I'm going to add 32 to this side. If I add 32 to this side, these two 32 will become 0. The m comes down. 60 plus 32 is 92, and that's my answer. Is it true? Well, m minus 32 equals 60. I'm going to substitute the m with 92. Minus 32 equals 60. And 92 minus 32 is indeed 60, which equals 60 on the side. Perfect. Carlos has white toy cars, and 50 toy trucks. Why not crash? So here is how many he has. He has y plus 15. This is how many toys he has. Okay, toy cars, this many cars, and this many trucks. So if he has 41 toys altogether, so I can change that expression to an equation. I know that this y plus 15 equals 41. And now that I have an equation, I can solve this, right? I'm going to do inverse, and the inverse of addition is minus 15. I'm going to subtract 15. Subtract 15. Remember, the point here is to make keep our balance on our equation, right? Whatever I do to one side, I do to the other side to keep it balanced. So this is 0, right? 15 and minus 15 is 0, and then bring down the y. And 15 minus 41 minus 15 on this side gives you 26, right? Well, the answer is y equals 26. You can always check. So the original equation is y plus 15 equals 41. Y is 26 plus 15 is 41. Is it really? 2 plus 6 is 5. 11 goes 1, 2 is 41. See, it worked. 41 equals 41. Okay, now it seems like we're done with day 24. Okay, that wasn't that bad. Okay, so I'm loading this up right now.